Welcome to the Master the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Welcome to another episode of Master the NEC, the podcast, where I talk about the National Electrical Code and all things electrically related. People submit questions about all types of things. If you're the first-time listener to the podcast, we have over 1,000+ episodes of all different type of topics for the electrical industry, whether it's bidding, estimating, hiring, firing, guerrilla marketing, growing your business, not just the National Electrical Code, but we do a lot with the NEC and talking about the changes and all that other good stuff. All of it, all you got to do is go to your whatever search engine you want. It really doesn't matter. You just go to Google, Bing, whatever it is, and you type in there, Master the NEC podcast, and you're going to see that we're on Spotify, Spreaker, Deezer, iHeartRadio, Apple Podcasts, Google Podcasts, and all those other wannabes out there have not been doing podcasts nearly as long as we have. So they can dabble in it a little bit, you know, the Jackersons of the world. But at the end of the day, they don't even come close. So check it out. And you can hear a bunch of different topics that we talk about on the podcast. Also, it is July of 2026. So as most of you probably know by now, I am an NEC consultant for EC&M Magazine. I do write articles for them and videos and podcasts, and I'm one of their code experts. And so look for that in July, in their July episode, I guess towards the end of July or somewhere in there. You'll see an episode in there where we're talking about the Inspector Intel, and it's a series that I'm starting for them. Wanted to give them something a little different. So we'll be exploring the relationship between inspectors and electricians and all that kind of good stuff. So that's going to be a good series, especially if you've ever had a run-in with an inspector, or if you're an inspector and you've had that pesky electrician. There's a way that we all can meet in the middle. So make sure you check that out. It'll be on EC&M Magazine, and I'm sure it'll be on their digital format as well. So make sure you subscribe to that. It's free to get your subscription for EC&M Magazine. Great magazine, great publication. Mike Holt's been writing for them for well over, close to, I guess I shouldn't say well over, 40 years. So now I'm going to be writing for them. So again, I'm excited about the opportunity, and we'll see where it goes. If I do more for them in the future, we'll see. But anyway, that's what we got going on. Now, we're going to be doing, this is not a part 2 episode today. I did recently do an episode where I answered about, 10 questions that people submit and kind of gave some answers to that. We're going to do that again today. We're going to answer some questions that I get submitted all the time. And it's been a while since I've really done a lot of podcasting. And it's my first love, way more than I do videos. Because, to be honest with you, I don't know if you're like me, I'm always on the go. So whether I'm in the car, or I'm, wherever I'm at, it's easier for me to listen to a podcast than it is to sit down and watch a video. And the interesting thing about me with podcasting is I always make it a challenge, because the challenge is really for me to try to paint a mental picture. And that's how I create these little challenges for me when I do podcasting. It's not always that easy, but that's what I try to do. I try to paint this mental picture. All right, so we're going to do that today. We're going to pick up on some questions that get submitted. Jeff has compiled these for me, and I'm just answering them. As you folks know, I don't I don't cut, I don't edit, I don't do any of that stuff. I just give you straight from the gut and talk about the NEC. And I try to break it down so it's not overly code laden to the where you can't follow along unless you have your code book laying right out in front of you. But I might throw some references here or there. But remember, at all times when you're listening to this, you can always pause and go get your code book, open it up, read it, and back and forth, in and out as you listen. It's a great way to learn the code, great way to enjoy the conversation. And at all times, if you have any questions about anything that we talk about and you want to ask additional questions, then remember that you can go to our website, Fast Tracks System. That's TRAX, by the way, not TRACK. It's TRAX. So it's fast, just like it sounds, tracks, TRAX, system, SYSTEM.com. If you go there, you look under the info tab, you'll see where it says, Let's Ask Paul. And it's a very simple format for you to fill in the blanks, post your question, be as detailed as possible, and ask your question. And if I will potentially answer it in a podcast or an email directly back to you, but I will make sure that I try to get your answers. And if I don't, pester me, because I do get a lot of requests and a lot of them don't make it to a podcast. I just answer the question or whatnot. But again, I can't say I'm perfect, that some of them don't fall through the cracks, but it's not intentionally. I try to answer everything I can. I've been doing that for decades now, trying to answer people's questions. So again, that's a way you can reach out. Definitely through the website, fasttracksystem.com. Also, I should mention that we also have a message forum that you can go over to and post questions. It's free. All you got to do is register over on NECCHAT.com. So just like it sounds, NEC chat. And you can go over to it and join. And we have some free lesson. We have a free lesson over there about ampacity, but also you can post your images, job sites, anything you want to post on there. We'd love to have you over on NECChat.com. All right, first question we have. Hey, Paul, I love your podcast. I do have a question for you. Can you use the NEC's standard overcurrent device size rule for transformer secondary conductors the same way you might for general branch circuit or feeder conductors? Thanks again for all you do. Ignore the haters and keep posting those podcasts. All right, so appreciate it. Thanks for joining. And yeah, I act like the haters bother me, but I really could care less about them. My life's going to revolve around it anyway, and nobody will ever see their comments anyway, so eventually they'll get tired of it, but that's okay. So the quick answer to that is that this is where a lot of installations get into trouble, because it is very clear, since you're asking about the secondary conductors from a transformer, okay, is that the next size up rule in 240.4b does not apply. That's a general rule, okay? If it doesn't correspond, you go to the next standard size, those type of things. That does not apply to the secondary conductors for transformers. Okay, so the general rule, next size up in 240.4b, is not a blanket permission slip, especially not for transformer secondary conductors. In fact, right in 240.21c, it tells us that you cannot use 240.4b, the next size up rule. What does that mean? Well, that means you must follow the actual transformer secondary conductors rules being used, such as the 10-foot rule, the 25-foot rule, or one of the other specific provisions that are there in 240.21c. Those rules include limitations on conductor length. They've got limitation on conductors' ampacity, physical protection, how they're routed, whether or not they're in a raceway or not, and then, of course, the location of where the overcurrent protective device is. Now, another thing that I want people to not get confused about is that 450.3b deals with the transformer's overcurrent protection. Okay, so since we're talking secondary conductors, 450.4b is talking about protecting the transformer. Okay, so basically there's allowances for how long those conductors can be from the transformer secondary to the overcurrent protective device that they terminate into. Okay, so there's a length, and that's where we get the 10-foot rule, the 25-foot rule, the outside unlimited rule, but there's specific rules. And so an example of that would be where you couldn't use the next size up. Well, let's say we had a 500 kc mil copper that's 380 amps, and it was terminating onto a 400 amp overcurrent protected device. So that would be a problem because if we've determined based on a calculation that we're going to have a 400 amp device that's protecting the panel board, so the panel board has its own rules in 408.36, right? So if that's 400 amps, then those secondary conductors will only be good for 380 amps. They would not be able to go to the next size up rule and terminate on a 400 amp overcurrent device. Anywhere else it would be okay, typically, because as long as the calculated load doesn't exceed 380, if the breaker doesn't correspond to protected at 380, you go to the next standard size, 400. That does not come into play when it comes to transformer secondary conductors, okay? So you cannot do that. So I just want to make that clear that 450.3b deals with the transformer's overcurrent protection, okay? It's not the same thing as automatically protecting the transformer secondary conductors in themselves. You're still going to have to follow the rules, okay, in 240.21c for those secondary conductors. There's no getting around it. So the next size up rule does not come into play, okay? Now, the 2026 NEC also adds clarity by using a defined term for transformer secondary conductors, helping reduce confusion about where feeder rules begin and where the transformer secondary conductor rules apply. Okay, so I think as far as language-wise, it's still the same as it always has been. You knew you couldn't use the next size up rule for the secondary conductors on a transformer. And so if you're terminating them into a 400 amp overcurrent device in a panel on the secondary of a transformer, then those conductors have to have an ampacity of at least 400 amps, period. Because we can't use the next size up rule, where we could for feeders and in other applications, we can't here. So I think that's a very important part to remember. Transformer protection, secondary conductor protection, panel protection, right, that we talked about, the overcurrent device in a panel, 408.36, they are not the same type of conversion. So do not use 450.3b and try to ignore the rules in 240.21c. That's not how it works. You can protect the transformer, but it may not necessarily protect the conductors. And so when we're designing a system like that, we have to take all of these things into consideration. So, yeah, just don't think that 450.3b, for example, overrules anything else in the code like the conductors and, again, in 240.21c for protection. Don't assume that, because that's not how it works, okay? And that's the thing about the National Electrical Code is that we have to understand that at one moment you'll be in this part of the code, and the next minute, like 240.21c, right, for the secondary conductors, and then in the protection of those conductors. And then the next minute, you'll be in 450, which is purely about transformers. And what we're talking about overcurrent protection here, we're only talking about protecting the transformer. So, that's where it can get real confusing for people. But sometimes if you can really kind of put it in your mind and treat all these things separate, just don't forget there are other areas of the code that you have to venture into, right? So hopefully that makes sense. But that's a big one people run into. The next size up rule does not apply to the secondary conductors on a transformer. Let's see here. Great question, though. Next one says, Paul, what changed in the 2026 NEC for service disconnects and emergency disconnects at 1 and 2 family dwellings? Okay, well, most all of you remember the advent of the requirements in 230.85 under the 2023 code, right? Which required the emergency disconnect for those 1 and 2 family dwellings. That was added. We've been toying with that for a couple cycles. It got added in 2023. That's people have gotten used to that. At least if you're in the 2023, you got used to that. You're going to put emergency disconnect outside. That emergency disconnect may also be a service disconnect. It very well could be. It doesn't have to be. You could have a switch outside that would be a service rated, but use instead of that, be used as a emergency disconnect and still pass through and hit a service disconnect. You could still do that. Or you could have something outside that's not only the emergency disconnect, but also the service disconnect. And all this was given to us in 3 options. Of course, you can have a meter disconnect, which could serve as a emergency disconnect. And remember, we're not talking about a cutout switch on a disconnect. We're talking about a true disconnect, not that little lever that goes to under the meter. No, we're not talking about that. That is not a disconnect. Okay, so don't confuse it. But you get 3 options under 230.85 in the 2023 edition of the National Electrical Code. Now, in the 2026 edition, that separate emergency disconnect section was actually deleted, and the concept was reincorporated into a revision to 230.70. So it didn't go away. Okay, didn't go away. It just got reincorporated into 230.70. So the service disconnect for a 1 and 2 family dwelling is now required to be readily accessible outdoor location, either on the dwelling unit or within sight of the dwelling unit. Significant changes when it comes to that. All right. So the service disconnect mean, again, readily accessible. That didn't change. But the outdoor location, either on the dwelling or within sight of the dwelling, that would be an example where it would be maybe offset away from the dwelling on a pole and panel or board or whatnot, then that type of thing. So still doable to do that. Obviously, it would be within sight, within sights, within 50 feet and sight, right? Now, the 2026 also required that the service disconnect to be marked service disconnect. That was, again, service disconnects were required to be marked service disconnect, but this is very clear. And for 1 and 2 family dwellings, the enclosure of the service disconnect is also required to be marked emergency disconnect using the marking format that is given in the NEC. Okay. So the 2026 version did not eliminate the emergency disconnect concept. It just folded that concept into the service disconnect rules for 1 and 2 family dwellings. That's all it did, right? So instead of it being purely something that you would see in 230.85, now you're seeing that rolled into 230.70A, 230.70B, and all that kind of stuff. So it's not gone. People say, where did it go? Did it disappear? No, you still have the emergency disconnect requirements and all that, but it's just been rolled into 230.70. So not gone, just kind of re-rolled into another section in the code. That's all. Okay, still there. Let's see. The next question we have is Paul, in the 2026 NEC, can we still say that Chapter 8 communication systems are mostly independent from Chapters 1 through 7? Well, not like they used to be. Okay. Historically, Chapter 8 was a special status, if you will. It was generally not subject to Chapters 1 through 7 rules, unless, of course, Chapter 8 specifically referenced those requirements. And, of course, if it did, then they obviously would be applicable because they made reference to them, right? But the 2026 code changed that structure. So under Section 90.3, and there's a specific figure there, this was all revised, and now Chapter 8 is no longer treated as a standalone chapter. In the same way. So it basically, Chapter 8, which is communication systems, and then, of course, outside and entering buildings, it is incorporated now into a general requirement. It is not a standalone anymore, okay? So this is impactful because it makes it really clear. And the code changed these things when it used to be Chapters 1 through 4, apply broadly, and then 5, 6, and 7 supplemented and modified. But now adding 8 in there, it now makes it's not standalone anymore. It's literally incorporated into the requirements of the code. Okay. So the phrase, it's just low voltage, what people used to say, has become even a weaker statement now because the NEC, the 2026, many limited energy and communication installations inside buildings are more clearly tied to the broader scope of the NEC now. So by just pulling in Chapter 8, now brings in that communication systems are very much mandatory by the NEC and no longer treated as a standalone feature, if that makes sense. All right. Let's see here. Next question, Paul. Does the NEC use accessible readily accessible and within sight to mean the same thing? No, these are separate concepts. Okay. And I guess the easiest way for me to do this would be to paraphrase them out or try to explain each one of them separately. Accessible. So accessible in general means capable of being reached or exposed without damaging the building structure or finish. Okay. So if I have a box that has a cover on it, I take it off, the wiring inside of it's accessible. If I have a luminaire and I take the luminaire off, the conductors in there aren't required to be readily accessible. They're just required to be accessible. Are they accessible? Absolutely. I didn't remove any of the building structure or finish. I just removed the luminaire to get to it. So that's an accessible. Now, readily accessible is a higher standard. It means that the equipment can be reached quickly without having to climb over obstacles, climb under obstacles, remove stored materials, use portable ladders, or take any type of similar action to get to something. For example, in the code, you'll see that a GFCI device is required to be accessible. Okay. And so we'll see that and we'll say, okay, so, and in fact, if you go to 210.8, that did not change in the code. Just so you go to 210.8 and you read it. And what does it says? It says, in fact, it has to be readily accessible. That is a higher level than just accessible, because if it was just accessible, then I could get to it with a ladder. I could get to it. Readily accessible means that, you know what, to get to it, I can't resort to using something like a ladder, climbing in, climbing under, having to move some obstruction. That's a bigger threshold to have to meet. So example, we always use this one in a garage. If the receptacles in a garage are required to be GFCI protected, then you can either put the receptacle down low, not more than 5 feet high, which means it's going to be dedicated to the garage. If I put the GFCI in there, and at the end of that, that run of receptacles, it ends up with a receptacle in the ceiling for a garage door opener, for example, that circuit has to be GFCI protected. All of that is GFCI protected. But you wouldn't put the device in the ceiling, where you push it and reset it and trip it. No, you wouldn't do that because it would require a ladder to get to it. So it's not readily accessible. If you want to put it down at the 5 feet mark on one of those receptacles that are going around the garage, that's fine. If you want to put a breaker in the panel, that's fine. Protects the whole circuit. It's going to be GFCI protected. And thus, that receptacle at the end of that loop is going to be GFCI protected. But the GFCI device itself has to be readily accessible. And that means I'm not going to have to pull up a portable ladder or move any stored material, climb over or under any obstacle to get to it. No, I don't. It needs to be readily accessible. Don't need to go grab something else to be able to get to it. You know what I'm saying? So then the next one is within sight. That's a totally different, separate concept. Traditionally, it meant visible and not more than 50 feet away. Now, in the 2026 NEC, the within sight definition was removed from Article 100, and the concept is now addressed in 110.29. And that language expanded to cover equipment, buildings, and structures. So the takeaway that you want to kind of take away from this, where it's accessible, readily accessible, and of course within sight, it says, the key is don't try to mix these terms together. A disconnect may be accessible, but not readily accessible, whereas equipment may be readily accessible, but then again, it's not within sight. So the NEC uses each phrase independently for whatever the code tells you the criteria needs to be. If it says that it has to be readily accessible, then it's got to be readily accessible. And that means it's got to be what? Reachable quickly without having to climb over or under or remove stored material, use portable ladders to get to it, or something to that effect. Then it's not readily accessible. Okay? Within sight. If the code says, for example, a disconnect to a motor has to be within sight, then it needs to be visually within sight of the motor or the controller, and it also needs to be within 50 feet. Pretty simple, right? But that wouldn't come into the equation of readily accessible versus accessible. Each one of them get treated differently. And the code will tell you when something needs to be accessible, when it needs to be readily accessible, or when something needs to be within sight. those type of things. The code will dictate that to you. Some of the areas to be aware of in the 2026 is obviously 110.26, 110.29, things like that. So it's important to remember the scope outline of it, that these are distinctively different things. Okay, distinctively different things. Okay, next question that somebody has for me. It says, hey, Paul, love the podcast. I got a question for you that I've always wanted to ask. In the 2026 NEC, did the dwelling unit GFCI rule for garages and accessory buildings change? So yes, in the 2026 NEC revised the organization of 210.8A. So in the 2023, dwelling unit garages and certain accessory buildings were combined in the same list item. In the 2026 NEC, garages are separated into their own list item, and accessory buildings are addressed separately. Now, the change helps clarify that GFCI protection applies to receptacles in that area of accessory buildings that are not intended as habitable rooms and are limited to storage, work, and similar use. Now, the 2026 revision also modifies the exception for a factory-installed receptacle inside of an exhaust fan assembly. Okay, so the key takeaways here is a finished habitable room in an accessory building is not the same as a garage, storage area, workshop, or similar non-habitable area. So the 2026 NEC language makes that distinction very clear. So garages, yes, flat out, still in there. Okay, 210.8A2, still in there. The key here is item 3, which now separates it out and just talks about the accessory buildings. It says areas of accessory buildings not intended. Okay, so they're like unfinished. They're not intended as habitable rooms and limited to storage, work, and similar usage. So that's the key. If it's a accessory building and it's not going to be used as a habitable room, and it's only going to be used for storage, work, and similar type usage, then GFCI would be required. If it is an accessory building that is intended to be used as a habitable room, then you wouldn't require the GFCI protection. Make sense? So a finished habitable room in an accessory building is not the same as a garage. It's not the same as a storage area. It's not the same as a workshop. People have been asking for this for a long time because there's a lot of people accessory buildings, and because of the language, they were forcing this to require a GFCI protection, and it really was a finished off habitable room. And of course, you're going to have to go look at the building code and understanding habitable rooms and the definition of habitable rooms and all that kind of good stuff as well. So be aware of all that. But again, that is the change when it comes to that. And it just broke out from garage and similar areas of accessory buildings to kind of breaking them out separately. But, in our case, we can just go for our needs here when it comes to the NEC, we can skip the building code and argument with the building folks and just go right to the definitions, Article 100, and see if we don't have habitable room. And we do. It says a room in a building for living, sleeping, eating, or cooking, but excluding bathrooms, toilet rooms, closets, hallways, storage, or utility spaces, and similar areas. So if the accessory building is being used for living, sleeping, eating, cooking, okay, then, there you go. It's a habitable room. And if it's a habitable room, then it wouldn't require the GFCI protection. Anything other than that, GFCI protection. Okay, does that make sense? Okay, next question. Let's see here. Oh, by the way, I will remind you, if you want to learn more about thermography in electrician, you want to add thermal imaging to your scope of work. If you really want to understand thermal imaging and be able to add it, it's a great thing. If you really know how to use a thermography camera, you can really find a lot of things. But we don't want you to be crying wolf. So we have 2 great courses on that. We have the CTE, Certified Thermal Electrician Program, that's available through thermalelectrician.com. But you can also, all of these are available on our website as well as for the courses. And so there's a basic thermography course, which I think everybody should take. It covers way more than what electricians would need to know, but that's a basic course. And then, of course, we have the certification program, which you can get even deeper into if you want to understand it. We designed it so that it's not overly laden with pictures from thermal cameras and all that, because we really want you to use your thermal imaging camera, and we really want you to look at the numbers. Because what I've found with people is it's so easy to get misled by numbers rather than the actual pictures, rather than the actual numbers itself or the values. So we focus on the values. Okay, you can use your camera, but we are really focusing on the number values to teach you the difference so that you're not going to cry wolf. If you're interested in that, go check it out on our website, thermalelectrician.com. It's a great program. You'll learn a lot about thermography. And I feel a lot of electricians need to understand it and make sure you don't cry wolf if you go messing with one, that you truly understand how to work it. That's a key thing. All right, next question. Excuse me. It says, Paul, what are some of the big GFCI issues electricians miss in commercial or other than dwelling unit installations? Let's see. Well, I guess if I have to think about it, I think the biggest mistake is thinking that GFCI is only for a dwelling unit issue, right? So I guess that's the biggest thing that I would have to guard against for people to say, look, in 2023 NEC, you had 210.8b, which expanded GFCI requirements to other than dwellings. New or revised locations included areas with sinks and permanent provisions for food preparation, beverage preparation, cooking, buffet serving areas, and receptacles near aquariums, bait wells, and similar aquatic vessels. So all of this was incorporated into the 2023 edition of the NEC. These are uniquely different. They have nothing to do at all with dwelling applications. So this is like other than dwellings. So again, I think making people aware of that, and they're used to GFCI and they go into a commercial space and they forget that, guess what? You've got rules for GFCI applications here as well. And sometimes people forget that. They're so in tune to thinking GFCI is just a dwelling unit thing. It's not. Another practical issue is the sink rule. It is not just the receptacle location that matters. The rule can also apply where a cord and plug connected fixed or stationary appliance itself is within 6 feet of the top inside edge of the bowl or the sink. So that is another big one where people think it's just a stationary receptacle when and again, if you look at the National Electrical Code, it's different now, right? For example, in a commercial work, you don't stop at is this a kitchen? You look for sinks. You look for food and beverage preparation areas. You look for buffet serving areas now. You look at rooftops, garages, service bays, laundry areas, commercial laundry areas, locker rooms, and similar areas that are listed in 210.8b. So I guess for me, the key takeaway is let's not think that GFCI protection and all those requirements are locked specifically just into dwelling applications when there is a vast number of other areas that GFCI protection is required. So, I mean, that's just a reminder to people. I'm sure you're already aware of it. I just want to make sure you don't lose sight of it, because you could walk into somewhere that you're not familiar with whether or not GFCI was required. Again, last cycle, buffet was added, receptacles that are on a buffet line. Well, you might not have done that before. And if you're not thinking about it, you get in there and now you've got a requirement for those to be GFCI protected. And that was in the 2023 and it didn't change for the 2026. So I get that's the biggest area that I would say just be aware that there's more than just a dwelling unit when it comes to GFCIs. Okay, I don't know if that answers the question, but that is one area that I would tell you to be aware of. Let's see here. Next question is, where does the NEC require surge protection and what changed in the 2026 NEC? Well, in the 2023, surge protection devices are required for service supplying dwelling units. Okay, that was in 230.67. And then, of course, we had feeder level surge protection in 215.8 for certain types of occupancy. So we got that. I guess in the 2026 NEC, it's expanded that surge protection concept to include areas designed exclusively as sleeping quarters in fire stations, police stations, ambulance stations, rescue stations, ranger stations, and something similar. Just similar locations that would be very similar. The expansion that you see with those locations appeared in both the feeder and the service surge protection requirements. So it's just expanded use. Just be aware that it's expanding out, and the surge protection is now growing into, again, anything that would be running to feeder panels or whatnot that would be serving fire station, police station, ambulance, and so forth, that type of thing. So this is important because modern sleeping areas often contain life safety electronics, smoke alarms, AFCIs, GFCIs, communication equipment, and other sensitive electronic equipment. And the whole gear or the whole premise behind the surge protection is to try to protect those sensitive electronic equipment. And they may be in those specific areas. And obviously in those areas, you're going to have more chances of having things like smoke alarms and things like that. And so the protection is there. And they want to make sure that you keep that protection when it comes to surge protection, that type of thing. So surge protection is no longer just a dwelling unit conversation. It is, it is expanded over the last couple of years. And in the 2026 expands to focus into sleeping areas for emergency response and similar facilities. So if you've got a panel and a panel's located in these areas, then you're going to have to meet these rules. And 215.18a and 230.67a now, it's just expanded locations. Hopefully that makes sense. Let's see here. Let's see if I got another question here. I try to find as many as I can. Okay, here's we'll do this one, and this will be the last one for this episode. I don't want to get a little long. My last episode was pretty long, so I don't know if people actually listened to a whole hour. But this one says, "Hey Paul, when electrical equipment doors are open, can they block the required working space or egress path?" No, that's an easy one. So working space and egress are not measured only where the equipment doors are closed. They're measured when they're open. Now, in the 2023 NEC, it really already clarified that open equipment doors cannot impede access to and egress from the working space. We already established that. 2023 made it very clear. There was a discussion in ECM magazine, Electrical Contractor magazine, and they noted that the access or egress, if impeded, when it's open door equipment, reduces the path below 24 inches and 6.5 feet high, created a hazard. So the 2026 NEC continues refining this issue. So industry summaries explain that equipment doors swung open must be considered, and that the 24-inch egress path must remain available with equipment doors open to 90 degrees. So even if the equipment and the doors are open to 90 degrees, you still must maintain the 24-inch egress path around these doors. Now, they also revised 110.26C2 in the 2026 for large equipment by adding a feeder disconnect means installed under 225.33a to the large equipment egress rule, along with service disconnecting means under 230.71b. So, what's the takeaway for you and me? Electrical room layouts is not just about fitting the gear into the room. And a lot of times, these rooms are getting smaller and smaller because the engineers are trying to stuff as much as they can in there, because those are dead spaces that don't make the owners money. So we want to cram as much as we can, 10 pounds of crap in a 5-pound bag, so to speak. But you must account for this working space. When these doors are fully open, you must maintain that escape path, that egress path, okay? So whether it's large equipment egress rules are triggered or not, you still have these requirements that have to be met. And that's kind of clarification came in the 2026 edition of the NEC. So if you want to go look at it, you're going to be looking in the 2026, that is, you're going to be looking at 110.26a, 110.26c2, 225.33a, and of course, 230.71b. All of this is pretty much going to show you that we have to maintain this egress and access, and it has to be maintained even when those doors are wide open. Right? Even when they're open, then we have to maintain this clearance. Okay? And it's for safety. Electricians moving in and out. Anybody could get trapped in there during an incident. Okay, so again, all these rules, a lot of people complain about various rules. And I think at the end of the day, a lot of these rules are to protect you, the electrician, especially if you have to come back and service something, right? So working clearance is extremely important. If somebody starts storing stuff and you're asked to come back and do something and all this stuff is in the way, you should refuse it until they clean it out. Give you the path that you need, give you the clearance you need to work safely. Last thing we want is there have an arc flash incident and you get trapped in something and you get injured. We all have families. We all want to get back to our families every day. We're just out here to make a living, okay? We all still have a life. And so it's important. So some of the things that we require in the NEC, you may not like, you may not agree with, but this is a minimum safety standard. It's not a perfect, but it's about as minimal as we can get and still be effective. And can you go above the minimums? Absolutely. Can you go below the minimums? Absolutely not. And I think that's critically important for everybody to understand. All right. All right, folks, that's all we're going to talk about in this episode. Hopefully you got something. I know I talked about a lot of these at a 30,000 foot level. If you have any specific questions on any of this, remember, this is a two-way street. You can always reach out to me. Just go to fasttracksystem.com, go to the info tab. You'll see a drop down and you'll see the Let's Ask Paul button. Click on that, and please, by all means, feel free to send us a question, reference this episode, reference the question, or put your question in there based on what we talked about, and I will give you the best answer I can. All right? All right. Till next time, folks, stay safe. God bless. We'll catch you on another episode of Master the NEC podcast. Check it out.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.